In this video, let's see how we can assign regular key for an account for the first time. And please make sure to watch the previous video if you have not already. It's basic theoretical explanation of how set regular key works. So now let's open the documentation. Go to references and then transaction types. And then set regular key. Add, remove, or modify an account's regular key pair. So, a set regular key transaction assigns, changes, or removes the regular key pair associated with an account. But why do we even need a regular key to start with? So let's read this paragraph and understand it. You can protect your account by assigning a regular key pair to it and using it instead of the master key pair to sign transactions whenever possible. If your regular key pair is compromised, but your master key pair is not, you can use a set regular key transaction to regain control of your account. So you assign a regular key to your account and then store your master key in a safe place and start using the regular key for all the transactions of the master account. So if there is a virus or some computer network exploit or somehow you think the regular key is compromised, then you still have the master key and you can change the regular key for your account, keeping your account safe. So this method saves your master key from being exposed to any kind of exploits. So this is the syntax. Now let's create two XRPL accounts and consider one of them as master key pair, and let's set another account as regular key to the master key pair. So we generated two accounts on the test network. Let's get back to the editor. Let me reorganize this. Let us call this secret one, and then using it we shall derive master key pair. Let's copy and paste this and do the same for regular key pair. Let's call this secret 2, using which we shall derive the regular key pair. And then let me grab the family seed or secret of these two accounts. Let's consider this as the master key. Which derives the master key pair. So let's consider this for regular key. Okay, so let's have these secrets at one place. I like it this way. Now let's check the account information of the master account and also check for the flags it has. We know it's a new account, by the way, so there will be no flags, but let's write the code to check it anyway. So the command here is account info, we know that, and the account for which we are fetching the information is the master account. So let's output whatever is present inside account underscore data. Remember, we are fetching this information from master key. Okay, always remember that. And then let's even use a package called flag names, which we have been using in this course. I have already installed it. Let me import it in my script by copying this. So this is how we make use of flag names. Let me copy the whole thing as we just want to display it as of now. Let me paste it here. So this flag names takes two parameters, the first one being ledger entry type and the second one being the actual flags information. And it outputs array of all the flag names present on the account. So this outputs an empty array as there are no flags on this account yet. And this account info command's output does not have any information about regular key or signer list, as there are no regular key or signer lists set on this account. So the only authorization method for this account is via master key. So one thing to keep in mind, whenever there is only one way to authorize the transaction from an account, and if you try to disable that method, it will always fail. The transaction would always fail. In this case, only master key can sign the transactions from this master account, so you cannot disable it. If you still try to disable it, it will start throwing errors. Let's try and look at the result. So let's write a payload to try to disable the master key. So for that we need a transaction type called account set. We have seen this a lot in our previous videos. And the account on which we are trying this is master account. So its address is present inside master.address. Fee, I'll fix it to 10 drops. You have to fetch it from the network. Sequence, we should get it from the master account. Account underscore data dot sequence. Now, set flag. Let's open up the documentation and go to this account set transaction type. So let's scroll down and look for the flags. And we have it here, disable master. And its integer value is 4. Let's use it. So set this flag on the master account. So let's sign this. So this is the payload, and we are signing it with the master key pair. And then we will submit this signed transaction to the network. And we already know the command. The command is submit. This should technically throw error because there is no other alternate way to authorize the transactions from this main account or master account. So trying to disable the only way from which you can authorize the transaction, it will surely fail. Let's check that. Okay, as expected, the transaction failed. Let's read the message. The operation would remove the ability to sign transactions with the account, and the code is no alternative key, which makes complete sense. So this is something to always keep in mind, that if there is only one way to authorize transactions from an account, you cannot disable or remove it. In this case, it's master key and you cannot disable it for now. So let's comment this snippet of code here. We will get back to this code shortly, so we still need it. Let's even label it as disabling master key. Okay, so now let's write code to assign a regular key for the first time to this master account. Let's look at the syntax one more time from the documentation. Okay, set regular key, account fee, regular key. Okay, let's get back. So the transaction type is set regular key with S, R and K in capital. The account on which we are setting the regular key is the master key. And fee, well, this is important. This is the only transaction where transaction fee can be set to 0. It can be 0 only when the master account does not have password spent flag set. We saw previously that there were no flags on master account, so the fee can be set to 0. But once this transaction is executed, the master account will have password spent flag set on it automatically, and it gets removed when the master account receives some XRP payment. And one interesting thing to note here is this transaction will have more precedence over any other transactions in the ledger, even though the transaction fee is 0 here. Maybe because you are executing this transaction because your account got compromised, so this transaction executes before any other transactions in the ledger. So next, there is regular key field, which takes the R address of the alternate account for us, which is present inside constant regular. Well, let me show the constant regular way at the top here. And then the sequence number of master account. Always remember the sequence number should be that of the master account and not the regular key account, okay? So this transaction is done on behalf of the master account and hence the sequence number should be that of the master account. You can cross-check for confirmation. We are getting this from master account and fetching the sequence number of the master account, okay? And we are signing this transaction with master key as it is the first time we are setting the regular key. Okay, we will get back to this fee and alter the code to check the presence of password spent flag and then decide on the fee accordingly. So let's execute this code. Well, this is the output of the transaction. And as you can see, it was successful and you can cross verify that the fee was 0. So let me get back. Let me comment this code and check the flags on the master account. Let me scroll up to show you the code. Okay, this is the code. Let us execute it. So as you can see, there is password spent flag set up on the master account. And since we have password spent flag on the master account, the fee cannot be 0 now until this password spent flag is present on our master account, okay? We cannot have the fee as 0. We need to restructure this code. And also, we can see the regular key information in this account info commands output. Now this password spent flag gets removed automatically when the master account receives some XRP payment. And then we can again run set regular key transaction with 0 fee. But before that, try executing set regular key transaction with 0 fee. It will throw error this time as the account has password spent flag now. Let's try that. So as you can see, it tells you that the fee is insufficient. Okay, let's get back, or let's copy the R address of master account and send some XRP to it, by which this flag gets removed automatically. Okay, this is the master account's R address. Let's copy it and then switch to index.ts file, which we always use to make the payment transactions. This one. So let me clear this. So node, the file name is index and one references for family seed, and this is the master keys R address. We are sending 0.1 XRP from this account, from this family seed. Okay, the transaction was successful, which should actually remove the password spent flag from our master account. Let's check that. So before that, let's comment these snippet of code. So we are executing for this, that is fetching the information of the master account. And as you can see, the flag is 0, which means it doesn't have any flag, that is the password spent flag has been removed automatically. Okay. Now again, you can run this set regular key transaction with 0 fees since the account does not have password spent flag anymore. Let's check that. And as you can see, the transaction was successful. So with this basic knowledge, let's fix the fee field's value. Just check for the presence of password spent flag. If present, you cannot have fee as 0. If not, if password spent flag is not present on your account, you can have 0 fee for this set regular key transaction. Simple. So let's scroll up, and instead of just displaying it, let's store this array in a constant. Let's call it flags. So this returns array of all the flag names, that is flags present on an account. In this case on master account. So flags.includes, if it includes it returns true, if not it returns false. So we are checking for the flag, that is the exact name is LSF password spent. If this is actually present inside this array, it will return true. So if it's present, we need to fetch the fee from the network. In this case, I'll just hard code it to 10. So if this flag is not present, the transaction fee can be 0. So this saves your users transaction fee. I know that the transaction fee is very low as of now, but in the future it might increase because of network load. So it's worth the effort. It's just one line of code, so you better do it. Okay, so let me comment this and label it as setting or assigning regular key for the first time. Okay, now that we have set the regular key, let's make a payment transaction from both the master key and from regular key account. Okay, so the transaction type, wait, let me just remove this and copy paste the payload I had already written for other files. Let me modify this. So the account is master account, so master.address. Let me hard code some destination address, and then this is, we are transferring 1 XRP, and the sequence, this sequence number should be that of the master account because we are executing this on behalf of master account. Cross verify it. We are getting this account data from master account. Okay, and we don't need this because we are not writing the code for it, so let us just remove it. Let us even comment these 2 lines of code for now. We don't need it here. That's it. We are signing this transaction with the master key, and it should work obviously, but let's check that. So this transaction was successful. Great. Now let's sign the same transaction using regular key. Everything is same, the payload is same, just sign it using regular key. Let's execute this. And as you can see, this transaction was successful, which means regular key was able to sign the transaction of master account. Okay, so now both these accounts can authorize the transactions of master account, which means now we have more than one way of authorizing transactions from master account. So let me comment this. Now let's try to disable the master key. Let's uncomment this code. As you know, now we have 2 ways to authorize the transactions, using master key as well as regular key, but still you cannot disable the master key using regular key. Let's see that. Okay, let's try to execute this code using regular key. It should throw error because only master key can disable the master key. This is the one transaction which regular key can't execute on behalf of master account. Okay, now let's get back and execute this payload using the master key, which should actually disable the master key. So let's scroll up. There is no need to change anything in this payload. We just have to sign it using the master key. That's it. Let's execute this. Okay, this transaction disables the master key. To check that, let's do a payment transaction. Let me comment this snippet of code and then uncomment this payment transaction code. Everything remains same. We are trying to do a payment from the master key and trying to sign it with the master key, but the master key has been disabled. Let's see what happens. As you can see, it fails with the message that master key is disabled. So you cannot do this any of the transactions using master key now, but you can do all the transactions using regular key and on behalf of the master account. So let's execute the same payment transaction by signing it with regular key, and it works. There is one very interesting thing here. Do you think we can remove the disable master flag set on the master account? Let's check that. So let me comment this code. And we know that there is a field called clear flag. Instead of set flag, to remove this flag, we always use clear flag, right? So do you think we can just remove the disable flag from our master key account using master key itself? I hope not, because master key has already been disabled, right? So master key is disabled, message will be thrown. But you can execute transactions on behalf of master key using the regular key. So now this flag which disables the master key can be revoked or removed from the master account. Okay, now let me make a payment transaction using master key. Oops. We have another, we shall comment this out. Now if disable master flag has been removed from master key, we must be able to sign this transaction using master account, and we can do that. So this is interesting. So using regular key, you cannot disable the master key, but using regular key, you can remove the disable master flag from your master account, which enables signing of transactions from master account once again. So this is it for assigning regular key for your master account. In our next video, let's see how we can change the already set regular key from our master account.